Okay, so lesson 6.4, we're going to solve equations with rational numbers. Now, rational numbers include fractions and decimal numbers, okay? So how do we deal with those? Well, the nice part about it is we're still going to work with inverses, okay, inverse operations, undoing, addition, and subtraction, and so on. We just have to bring it, our fraction rules, and we have to use our decimal rules. So in this particular case here, in A, G minus 13.6 equals 8 and 23/100ths, we would do the same thing here as if these were whole numbers. So I look at this and I go, okay, I want to isolate G by itself, which means I need to get rid of a minus 13.6 from both sides of the equation. Well, how do I do that? Well, the opposite of minus is to add. So I'm going to add 13.6 to both sides of the equation. Now, I didn't line my decimal here. I'm going to erase this and line my decimals up a little better. 13.6, okay? So I'm adding, and again, if you like the little dotted line here to show your sides of your equation, okay? So negative 13.6 and positive 13.6 cancel each other out. So I am left with my variable on the left-hand side of the equation in this particular case. Equals, well, I simply have to add these two together. This would be a 0, so 3, 6 and 2 is 8. My decimal, 8 plus 3 is 11. Carry a 1, 11 is 2, 2183. And so if we check it, okay, and checking we should continue, continue. So my 2183 goes here for G. 2183. That's a very bad 8 minus 13.6. Is that equal to 8 and 23/100ths? Now, for the sake of time, it is. But if you needed to, you could set it up on the side of your paper and check to see, or even put it in a calculator and check to see if those work out. But yes, they do. So again, you'll notice here, nothing is different other than we have to take into account our decimals. So, okay, fractions. Now, still isolating the variable, which means I have to get rid of a plus 14 1/4. Okay, well, how do I do that? Well, I'm going to have to do the opposite and subtract 14 1/4 from both sides. The real issue here is not that you add or subtract from both sides. Again, those 4 1/4s are going to go away and my y is going to come down. Okay. The real question is, how do I deal with this? Okay. Now, I know in this particular case to go 2 minus 4 1/4, I'm going to have to go 4 1/4 minus 2 and make it negative. Okay. So even if I have to 4 1/4 minus 2 and then go through, well, how do I do that? Okay. And you have choices. Now in this particular case, 4 minus 2, well, 4 minus 2 is 2. Okay, so you're going to be left with 2 1/4 when you get all said and done with in this particular case. Now, you have other choices of things that you could do, and that's where we get a little bit, I don't want to say sketchy, but, well, we do get a little bit sketchy because we have to remember, how do I deal with fractions and decimals? You could do this as a decimal problem. 4.25 minus 2. Well, $4.25 minus 2, well, that leaves you $2.25. You could have done this as a fraction problem if you wanted to. In this particular case, I could have taken this and gone to an improper fraction. 4 times 4 is 16 plus 1 is a 17, so 17/4 minus 2, 2 over 1. And then from here, I could have gone through and to subtract my fractions, I need common denominators, which would have made this a 4. So multiplying by 4 makes this an 8. And I go through all of those steps. And 17 minus 8 is 9/4, which ends up being 2 1/4. So you have to, decide what is going to be the best method in this case for dealing with these fractions. In this particular case, you'll notice we have a fraction and we have a decimal. Now this one here probably is best to go ahead and change this to a decimal. Okay, 1/4 is 0.25. So if I rewrite my equation using all decimals in this case, well, now isolate your variable and get rid of your plus 0.25. Well, to undo a plus 0.25, I subtract a 0.25 from both sides. All right, so if I subtract from both sides, 75 minus 25 is 50, so this is 0.50. That's a half. Okay. Now, if you wanted to, you could have done these as fractions. Okay, I'll go down here. Y equals, oh, sorry, not equals. Let me write that correctly. Y plus 1/4 equals 7.75 is 3/4. So now if you subtract 1/4 from both sides, okay, so you could have done this as fractions. Positive and negative 1/4 cancel. There's your y. 3/4 minus 1/4 is 2/4, or a half. And either way, though, you end up with a half. So you sort of have choices in how you're going to deal with these and putting them together. Now, 1/4 times y equals 3/5. And here are some steps, and this is where knowing something about a reciprocal comes into play. Okay? A reciprocal, definition of a reciprocal, one of two numbers whose product is 1, also called a multiplicative inverse. And the reason I throw in this may not make a whole lot of sense to you, but this term is important because we can use this idea of a reciprocal to our advantage. Okay? What can I do to 1/4? What can I multiply by 1/4 to make a 1? Because I want this, instead of being a fraction, I want this to be 1y. Well, one of the things about any number is any number times its reciprocal is always equal to 1. So the reciprocal of 1/4 is 4/1. Okay, it's the fraction flipped upside down. And notice here, if I multiply the fraction, the number by its fraction, 1 times 4 is 4, 4 times 1 is 4, but 4 divided by 4 is 1. Okay, so any number times its reciprocal is 1. So using that knowledge to my benefit, I'm going to multiply both sides of this equation by the reciprocal of 1/4, which is 4/1. And you'll notice here, again, my cross reductions. All of this stuff ends up equaling 1y, which is what I want. I want the y on the one side of the equation by itself. Now, if I multiply this side by 4/1, I'm going to go over to the right side and also multiply by 4/1. And I'm going to use my fraction rules to reduce this if I can. Well, there are no cross reductions or reductions and so on. So in this particular case, just go ahead and multiply across. 3 times 4 is 12. And 5 times 1 is 5. And if you wanted to, you could have gone ahead and, or at this point, you could go ahead and change that. Let's see, this would be 2 and 2/5. So y is equal to 2 and 2/5. Okay. Same thing, reciprocal, I'm trying to get y by itself, so I want to get rid of 2/3. What can I multiply by, or 2/3 by to make 1, to get rid of the 2/3 and make it into a whole number? Well, the reciprocal of 2/3 is 3/2. And you'll notice here, cross reduce, cross reduce, cross reduce, cross reduce. I shouldn't say reduce because we're not actually making it smaller. Okay, 1 times 1 is 1, 1 times 1 is 1. So all of this is 1y, which is what I want. I want 1y on one side, and I want the solution to the problem on the other side. So if I'm going to multiply by 3/2 on the right hand or the left hand side, I'm going to multiply by 3/2 on the right hand side. And I am going to cross reduce, cross simplify where I have the options. So the 2's will simplify. That will take care of it. 3 times 1 is 3. 5 times 1 is 5. Oh, one thing I didn't do is I didn't check my work. So let's go ahead and on this one, because I didn't do it in the previous one. Let me check it on here. So 2/3 times our solution, y, which is our y in this case, so 3/5. Is that equal to 2/5? Again, go back to the original expression. Okay. Now notice, when I simplify this, the 3's cross reduce. 2 times 1 is 2. 5 times 1 is 5. 2/5 is equal to 2/5. And it checks. So multiplying by a reciprocal, get used to using it. Okay, it will help simplify a lot of those problems. So again, guessing that people are going to need help. This is one of those chapters where help is probably required. Come see me when you get stuck, and we'll talk through it. So, all right, go ahead and get some practice going. Good luck.